That's Andrew, Bill, you, Dustin, and Marshall. And we're group number 2, and this is our Balsa Wood Bridge project. Wrong way.
You only saved the question.
Oh, there we go. Alright, the goals of our project were to design the bridge to have a high strength to weight ratio. And that basically means you want the bridge to weigh the least amount and hold the most weight. We also wanted it to be ductile without deflecting over 1/2 inch. We wanted it to be easily constructed, and we wanted to meet the design specifications.
Alright, so these are the design specs. You know, we had to go somewhere between 24 and 32 inches with a 6-inch minimum roadway and a 6-inch vertical clearance. And this is just the testing apparatus.
All right, so we got our balsa wood from Hobby Lobby in Anderson. Most of it was a 1/4 inch thick, except for a small piece on the bottom. It's not thick here, but it was a 16th. All the joints were cut on a table saw. We put some dados to increase the surface area and the gluing surface. I thought it might give it a little added strength. We used Type Bond 3 wood glue. I thought about using Gorilla Glue, but because of the balsa wood, it's so weak, any glue is really okay. It didn't really matter either. We used clamps to clamp all of the glue joints, and chisel to clean up all the dried glue when it was dry. Here's a CAD drawing of our bridge. Speaks for itself. We had some supports here to keep it from buckling from side to side. I couldn't tell from the way it failed that they really did anything. If we had to do it over, I think we could get rid of those.
This is the before and after bridge testing. This is what the final bridge looked like after construction. You can see the 4-inch, 8-inch plate with the middle bar holding all the weight. Pretty much acted like a point load though. You can see our trusses and what we have going on. Most of the deck did most of the work. And this is after it failed. You can see all the sharp splinters and how mostly the truss is still intact. And mostly the sharp splinters is why we don't have it here with us today. Thought it was kind of dangerous to carry around. With the results, the bridge weighed 0.858 pounds. Max load is 324 pounds with a strength to weight ratio of 377, which is 5th out of 11. Pretty good. It deflected 0.4 inches, and one of our goals was to have good deflection, because what you want in the real world is deflection, so that you can know that a lot of stress is happening in your bridge, and you will do something about it before it fails. And luckily our bridge did not have too much deflection to the point where it failed, as far as the design specs.
Our bridge uses a one-way slab to distribute the load from the road deck to the girders. And if you can go back to the CAD drawing, the middle 2 girders transfer the load to the supports, and the outer 2 girders transfer some of the load to the truss and also some of the load to the support. Like Luke said, the lateral bracing was used for extra stability. Our bridge was a kind of a combination between a girder bridge and a truss bridge. We wanted to use the truss to add strength, and we used the girders to try to make the bridge more ductile.
As I was saying, it was very ductile in the fact that it deflected 0.4 inches before it completely failed. So like they're saying, it gave you a chance to see the failure and correct it before it completely fall through. That would be in the real world sense when you have the bridge and it starts to fail. You'd be able to correct it before it just completely falls through and you have any problems. The way we designed it was more a real world sense of a bridge, a car driving over it, because we had it set up that the girders and the trusses would distribute the load throughout the whole bridge. That if a car drove completely over it, it would be completely distributed. With this project though, it was more of a center point load. So if we could have done this differently, probably would have done more of a two-way instead of a one-way. That would, especially at the truss connections, that would have force to be transferred from the center out to those trusses, especially trusses at the center, and then we're able to support the load a lot better. We had pretty solid girders at the roller connection, which allowed it to deflect and not have too much problems with the support there. Another change that could have been made, I don't know if you can go all the way back to where it failed for that picture. Right down there. Right here, I don't know if you can see it too well. If we had the bridge show you probably a little better. But you can see on this where the middle truss setup started to completely come undone. The glue came undone. And for most of the failure, it was kind of free floating. So we probably could have gotten rid of that and also made these trusses a little bit thinner and probably still hold close to the same weight, or hold close to have the same strength and be a little bit lighter, so our strength to weight ratio would have been a little bit higher. And that's about all I got. Any questions?
Okay, so quick answers. Does anyone have a question for you? So I see that the loads on the slab weren't fully transferred to your truss system. It almost makes me feel like your truss system wasn't fully utilized. What would you do different next time if you build this bridge again to make sure you take advantage of your well-built truss system?
I think there was two supports going down through the surface of the bridge deck, and one of them just pulled apart immediately almost. And I think that was because I had to sand it a lot to get to be able to pass a 3-inch block through there. So I think I might have like broke that piece of wood even before we tested it. So if I was to do it again, I would have given myself a little bit more room. Definitely put bigger members there, and I think that would have held up the bridge and transferred more of the load through the truss instead
The
of.
glue connection was going to be sufficient to hold it up.
It would have been, because underneath the deck, sandwiched underneath the deck was 2 pieces of wood running underneath that deck that would have held us in place a little better.
Any other ideas to transfer the loads to the side truss members other than the columns you had or the members you had in the center of the roadway?
I think if we had run more girders in the short direction versus the two we had instead of the long direction, it would, especially in the center where the connections were at, would help transfer the load to the trusses instead of just the 2 girders down the middle taking the whole force of the load.
That's another right. Any other questions to this group?
Do you know what caused it to torque the way it did?
We think it was the fact that parts of the certain joint connections failed before others on the truss, and so they were holding no load while others were. And so they had that weight going that way, clean in the moment.
Was the loading fully axial? Was it a fully vertical, perfect loading condition? Maybe the load was also imperfect.
Right.
When we were putting loads, we were putting it a little eccentric, right? And it was causing some load.
Plate was doing that too.
If you go back to the picture, there wasn't a cross. It was on either side, like you had a diagonal beam here and then one on the other side going the other way. And that's how it was. This load was pushing this way and this one was pushing that way. So it kind of
Oh yeah, that's a beautiful point, exactly. Right there in your report, definitely. That's it. Would you do it different next time?
Yeah, I would, yeah, we put a cross piece in
Or
there.
maybe just like,
Or maybe just get rid of that altogether. I think it added a lot more weight than
All right, great presentation, thank you. guys.
Thank you.